You made it! Welcome to Vienna. We are so glad you're here. This event is part of Vienna Up, the Startup Festival. Have you got your Vienna Up wristband? Put it on and enjoy special offers and activities. Swing by the festival home base, say hi, hang out, and enjoy Viennese Hour to sample local food, wine, beer, and soft drinks for free. And have some fun while making new connections. Visit partnering traditional Viennese coffee houses to sip a free melange, meet new contacts, check your email, or just have ideas both crazy and grand. Enjoy Vienna. Go to viennaup.com, sign up for the newsletter for daily highlights, and we'll see you at the home base.
Okay, how about that? Yay, that's much better. Okay, welcome to another live WeAreDevelopers Day. This time live with people. Normally we just do those things on the internet. So first up, there's a code of conduct. So don't be a terrible person. We're going to show a quick video what that means for us. That's just a legal thing that we show the video, that we have it. But then we'll explain to you what that means to me. So can we switch that quickly on? Don't be a terrible person and actually don't make anybody else feel bad about what they are, who they are, or where they are actually coming from. If you see anything like that, if you feel attacked by somebody, if you feel that something we said is out of order, please come to any of us and we will actually deal with that accordingly. There's a balcony, we can throw people over it, all kinds of things can happen. So that's what we're doing here. Secondly, this is in person here for a change. So this is our brand new office. I'm Chris, I'm the VP of Developer Relations for WeAreDevelopers. I live in Berlin, so I have no idea about the area here as well. No idea about the building, that's the first time I'm in here as well. What I know is that this is also a shared space. So down there are other offices of people that are not working for us, so don't go in there, don't annoy them. You can actually use the facilities up here. You can hang around here. It's great. It's beautiful. If you need to smoke, you can go outside on the balcony. If you need to go to the toilet, don't go to the balcony. Go down one floor and there's facilities there for you. And without further ado, happy Pride Month as well. So I feel very, very happy that we can celebrate for a whole month that people show love to each other. And I think that's a great thing. So whatever you are, whoever you love, please show it to people and nobody should be annoyed about that. But let's talk about web performance today because that's what we're here for. And I only have a quick introductory talk by me, and then we hand over to Clemens, who's going to be one of our... Clemens? No. Another Clemens, what the hell? I hand over to Clemens for another talk, and that goes much deeper into the subject matter. So my thing is, I've been a web developer for 25 years. I worked on Firefox, I worked on Microsoft Edge, I worked on the Yahoo homepage, I worked on lots of websites. And the performance thing came up in 2005, 2006 when we started talking about it the first time. And I am overwhelmed by it. So I appreciate if anybody of you really doesn't understand what's going on there, because there's so much to take in. I mean, these are all just words that actually happen in the world of performance that you should know about, but you also should not feel bad if you don't, because not everybody can know all these things. So I'm going to go through a few resources that actually allows you to understand what these things are. I'm writer of the Dev Digest newsletter for WeAreDevelopers as well. It's 150,000 subscribers. I write it every Friday, and every Monday it comes out a blog post. And I collected all the performance talks under this QR code here, or at wearedevelopers.com/performance.html. So every week there's something new there in case you want to know something about performance. All the resources in this talk that I'm talking about today are in this barcode. So you can actually scan that on that QR code, or you can type in github.com/codepoet/649852 if you want to as well. But that's not as performant as just scanning that QR code. And that's always a good thing to have, because then you don't need to look at the URLs, but you can actually see what the resources are about that I'm talking about. I think the first thing that as engineers we sometimes underappreciate is that it's not just numbers when it comes to performance. It's just on how fast a page loads, how fast it renders, how fast it becomes responsive, but also what it does to our users. And this is a great article by Tammy Everts about the psychology of site speed and human happiness. How happy our developers or US developers are when the websites are faster, and how much happier our end users are when the thing doesn't annoy them. How many times were you actually standing there trying to book a ticket or trying to pay for something and the spinning button just drove you crazy? And that's not happiness, just annoyance. I was in McDonald's for the first time for years, and this whole upsell thing, like I just want a burger, and you press the button and there's another button there that's grayed out but clickable. And you're like, no, that's not a button that's clickable. And I'm wondering why the thing is so slow. And it wasn't slow, I wasn't aware that I could skip the thing, but it basically didn't show me a spinner or anything. So it's very important that we make our users feel not stupid with our interfaces. And interfaces are not performant, make people feel that they're actually slow themselves. So let's start with some courses and resources we have out there. There's a great one from html.dev, which is a wonderful website just about HTML and the intricacies of the problems with it. And that was from last Christmas advent calendar kind of thing. And it's just getting started with web performance. And it's not like, here's the science behind it and you have to be the perfect developer to understand it. It's just like, here's a few things to get started. The MDN guide, the Mozilla Web Docs, is something that I wrote for use as well. That's a good overview of to get you started in the web performance world as well. Google has the Learn Performance developer course that they released a month ago or so. And that's a really in-depth course, but oftentimes it's like how Google sees the web and how Google sees performance rather than like how everybody sees it as well. I find it very frustrating when there's lots of acronyms that are not explained, and I don't know what they mean. And we have a quiz later on, so you might see some of those as well. And then there's, of course, advice that always works and you will see everywhere. The biggest thing that Google came up with as well was the Core Web Vitals, CWV. And that one has become a very like de facto standard to test your website and to test your web app and to make sure that you have good numbers there. Like when you remember Lighthouse in the developer tools of Chrome, for example, showed these Core Web Vitals, and they also adhere to how good your website was ranking in search engine optimization. So having good Core Web Vitals means you're actually listed higher in Google. But seeing that Google now gives you AI summaries rather than websites any longer, I don't know if that's that much of a carrot any longer, because we don't even know where that's going, except for it gives you answers like you have to put glue in your pizza cheese to make it better. So it's an interesting one. The developer tools was something that I worked on before I went to WeAreDevelopers. I was the product manager of the Chromium developer tools for Microsoft, and they're hard to understand. The performance ones give you every detail you ever need, but you also need to be an expert to understand them. And that's why I found this course, which is not an official documentation, actually really, really good to get you started in performance analysis using the Chrome Dev Tools, which also works in Microsoft Edge or in Brave or all the others that use the same Chromium developer tools. The other bit to always think about is like, have a fast host. It doesn't matter how fast you make a website. If the first load takes ages because your server is somewhere in the US on the West Coast and you're going from Austria there rather than having a closer server to your end users with a CDN, then you actually see that there's no point optimizing the end product if you can't even access that product. So ismyhostfastyet.com is a monthly comparison of all the offerings that you have and see where they fail and what they can do better. And it's a great thing to find out if you have a new product and you don't know where to host it yet, to pick the right one. Then there's more detailed advice that I find is more interesting once you got past the introductory things. And I love this talk by Harry Roberts. It's interesting because Harry Roberts used to be all over my Google search when I looked for him. Now it's all about that mass murderer in England, or that cop killer in England from the 1960s. It's also called Harry Roberts. So it was really hard to find that talk anymore. And that's about the head HTML document. The order of which you have things in the head makes a difference of 2 to 3 seconds of loading your page and actually rendering your page. And it's a very underappreciated problem. Most people don't even know that this order is an issue. So there's a great talk. There's also a slide deck that you can look up if you want to. And it inspired a product called capo.js. And that one allows you to actually copy and paste your head element in there, or give it a URL. And then in the developer tools, it gives you like the coloring and the best order that you should have. So you have the order that you have right now and the sorted order that you should be thinking about. And you take a look at it, and it tells you why it should be in that order and how many seconds you can actually shave off the loading or overall rendering of the page that you do. Sentry has a great 5 easy tips to improve your personal website performance, and it has very obvious things. Serving static HTML is a great thing. I love HTML to bits, and people don't understand that it's so powerful. We just don't have to make a React component out of everything. HTML can do a lot of stuff for us already. Optimizing images, using system fonts rather than loading that 25 megabyte font because you wanted to have that ampersand in the headline look differently. Remove render blocking resources, making sure your JavaScript gets loaded asynchronous, making sure your CSS is not too big in the header in there, and use less JavaScript in general. Optimizing images is another big pain point. Oftentimes you have a great running website, but the images are really slow and don't load asynchronously, don't load lazy. So you can use smaller formats like WebP and AVIF. They're now supported in all the browsers, including Safari. You can lazy load the images, and you have to set the dimensions. A lot of people don't do that, so the page starts jumping around when these things start loading, and it's really frustrating when I just started reading, for example. Interesting insights was that one, and the website looks absolutely horrid, but the data in it is absolutely impressive. It's about slow devices and what that means. Like, it doesn't really mean that your product loads fast and actually that you optimize the first interaction to loading. But if the machine has not much CPU or GPU, or the machine is actually busy with something else, you might have actually complete failures of your product, although the page loaded fast. So that's a very interesting thing to do. I always keep a very crappy old laptop at home as well, and a really horrible mobile phone to test my things on, because you can simulate bad devices and you can simulate latency, but you cannot do it properly. So always have some really horrible thing to try your things on, and it's interesting to see how much insight you get from that. Faster connectivity also doesn't mean faster websites. So the other problem is that we tested on our machines at home with a T1 going into it, or like a proper, I've got 150 megabyte line directly into my house. So of course everything looks great, but my end users, or as soon as I'm on the train, or as soon as I'm in a cafe, it looks completely different. So try that the website does not necessarily render fast on people's computers when they have a fast connectivity. There might be all kinds of things that go wrong in their computer as well. This is a great comparison between client-side and server-side rendering. A lot of people say like server-side rendering is much, much easier because then everything is cached. Other people want to do everything on the client, but you can't trust the client because it might be a slow machine with not enough RAM. Great points for pros and cons for each of those, and when to use what. If you really want to go deep dive, there's a rendering performance course on web dev as well from Google, and they also have a course on Udacity about browser rendering. This is hardcore. You really, if you work on a browser, you need to know this. If you worked ever in computer games, you actually know this stuff as well. But actually, as a normal web developer or just as a front-end developer, you would not know about this. But there's a lot of stuff to be gained by understanding how browsers do things. So don't create layers for the sake of creating layers. Don't actually have like long repaints because you created an animation that doesn't end, and all these kinds of bits and bobs that you can find in there. One thing that's coming up in the near future, and it's an interesting discussion point, which I wonder about if it's actually necessary, is the compute pressure API. This one would actually, where the browser would tell you that there is an issue with the machine right now, not having enough RAM or slowing down. And it gives it to you in 3 different levels. It says like critical, severe, and like I can't render anymore. So you can actually load content or load resources according to what the status of the machine is right now, or turn off animations. This happens in CSS automatically in most browsers, that actually if the machine cannot show the animation is not being shown. But if you do something in JavaScript and the machine cannot show it any longer, it would be interesting to get that kind of information from an API. So to wrap up, and I do this quickly here because I'm not the person to talk here, so we got more people for you to talk to, and you can ask questions scanning the QR code, and we have a Q&A after the other sessions. Always bet on the platform. If you really can do something that the browser already does for you, do it. Don't pretend that you know better than the browser. I worked on browsers for 20 years. We do everything to make that thing behave. We do everything to make that thing perform, and actually that it doesn't slow down your machine. Microsoft Edge and I'm very proud of that because I worked on that a year ago when I was still in Microsoft, finally now got rid of all the React in the browser itself. It's now using native web components that are actually supported in all browsers now. And the UI is 42% faster and 76% faster on devices without an SSD and less than 8 GB RAM. So the machine is not actually slowing down because you just opened Electron or the browser itself. The other question, of course, do we need JavaScript for everything? There's a great talk about the unbearable weight of massive JavaScript, showing just how much JavaScript we shove down the line just because we might need it later on, rather than we actually need it for the first render or actually for the first interaction. So things to consider. Check what HTML can do before reinventing it. One thing I find fascinating, for example, is that that anchor links have a ping attribute. So you don't need a JavaScript event handler on a link to actually say log it somewhere on your server side. You can just say ping to another URL, and when somebody clicks that link, it goes to both endpoints, first to the logging one, and then it follows the website. So that's something you don't need to do in JavaScript. Images have a loading attribute that allows you to define lazy loading or define upfront loading. Detailed summary is an HTML element that allows you to collapse things in the page without actually having to write that yourself. And that works with keyboard, that works with a screen reader and everything. The dialog element is for dialogues. The popover element is for little pop-ups that actually is, you can cancel it with escape, something you would have to write in JavaScript yourself as well. Data list allows you to make a select box and turn it into an autocomplete without actually having to write an autocomplete control. So let the browser handle things, but for that, you need to know what the browser can do. So caniuse.com and other baseline things will let you know what the browser can do these days. And don't trust people that say oh, Internet Explorer is used to be that, Safari is the new Internet Explorer. Safari moves not as fast as the others. We would love for Safari to be new every 4 weeks as well, but it's much, much better than it used to be. Do users want that feature, or do you want them to? A lot of times your product manager will come up oh, everybody needs that kind of feature in that app. And you're like, okay, then let's turn the telemetry on. And if in a month's time, nobody has used it, let's take it out again. Deleting code is so much fun, but we never get to do it as developers. That's the sad thing. So the best performing code is the one you never have to write. And think about that when you design your products. And that's it. So that's for me. So let's rock and roll for the rest of the evening. There will be QR codes that you can scan with that. At the end of the day, we're also going to have a quiz where you can win tickets for the WeAreDevelopers Congress in July in Berlin, which I'm now planning. And so that's going to be fun as well. 15,000 people, 600 speakers. So the first prize will be a ticket for 5 people. The second prize will be 2 tickets. The third one will be 1 ticket. And the first one also get a goodie bag. And you can all get one of those goodie bags when you get out of the room as well. Again, thank you for coming. And without further ado, I'm handing over to Clemens now. So just a lay of the land. Who here is an
machine where you could insert coins, and the cash counting machine was simply so fast that people didn't trust it. They didn't believe that it could count their coins so fast, so they wanted it to be recounted and recounted. What the bank did actually was they made the whole process slower until they got the result, and they played some bling bling sounds, sounding as if the machine was counting every single coin, and suddenly people trusted it.
Not bad, but you took long enough, so it's about time you get started.
Yeah.
Okay.
Finally.
Thank you very much.
Good thing takes a while, hopefully. Welcome, everyone. This talk is about Snappy UI and why it doesn't need a single-page application. First and foremost, who am I? My name is Clemens Helm. I'm web developer for about 20 years, so as you can tell, I'm a bit younger than Chris. In that time, I've been a freelancer. I've done around 100 web projects in several countries internationally. I've been CTO of a company. I've been mentor of several junior developers. And since a bit more than a year, I'm co-founder of the DevCraft Academy, where our goal is to help web developers become seniors in 6 months. If you're interested in that, come talk to me afterwards if you're on site, or check out devcraft.academy. Unfortunately, it's only in German. We might work on an English version later on, but for now you would have to use Google Translate. Cool, but let's get to the point. Front-end development today means single-page applications. It's kind of a synonym nowadays. When you're not really a web developer anymore, you're also not a front-end developer anymore. You're a React developer or an Angular developer or a Svelte developer. So these frameworks really determine our identities as developers. We really identify by the technology that we use, and we really bet our careers on these frameworks and libraries of the big companies that actually support these technologies. So how did we actually get there? It wasn't always like this. Back when I started, the internet and web development was a completely different place. So initially, when I was still in high school in the 90s and also in the early 2000s, there was no front-end development. We also didn't really talk about front-end and back-end. It was just, web development. And even if you were talking about web development, nobody knew what you were talking about because it was so fresh back then. And the way we developed these early web applications was only server-side. So that meant when you wanted to have an interaction, or when you opened an application, like today, you go to a URL, and then for every interaction that you made, you click the link, you submitted a form, it would send the request to the server, and then it would re-render the whole page. So the entire HTML document would be sent to you again, no matter how little this interaction was. And front-end these days was basically only HTML and CSS. Some weirdos played around with JavaScript a bit for creating funny little gimmicks, but I mean, nobody seriously considered JavaScript a programming language where you could do, serious application development. That changed a bit, or hold on, we've still got a slide here. The interaction, as I mentioned, was you requested a page, a request was sent to the server returned HTML, browser rendered HTML, you saw it, next interaction, same cycle again. So every interaction was this full page reload, right? So that changed with the dawn of Ajax. That was about in the mid-2000s. And what Ajax enabled us was to load parts of our page asynchronously, or to fetch some data later on and replace parts of the page asynchronously without always having to reload the entire page. And all of a sudden, it became more interesting to use JavaScript in the front end, because this way we could build more performant and faster applications that had a better user experience. And we could also do things that we weren't able to do before, because some applications are simply not possible when on every interaction you have to reload the page. Imagine something like, I don't know, Google Maps, how that would work if every time you wanted to move the map a little bit or you clicked an element on the map, the entire page would refresh. Nobody would ever use that. Pardon? Mapquest.com. Yeah, okay. Did anyone use that back then?
Was the only thing available, yeah.
Okay. Yeah, unless people have no other choice. So the interaction changed a bit. I mean, the initial page load was still the same, right? You requested a page, browser gave you the HTML, server gave you the HTML, browser rendered the HTML, you saw the initial page. But then on every interaction, your browser would send this asynchronous request to the server with JavaScript. And the server back then would usually reply with an HTML snippet. It wasn't JSON or anything back then usually. It was an HTML snippet, and then your front-end code would know where to insert this HTML snippet. So that was the time of having these huge JavaScript files with a lot of jQuery statements that did some wild DOM manipulation, a lot of spaghetti codes, really hard to maintain. And yeah, but it gave us a better user experience because we weren't bound to this page re-render or reload cycle anymore. So the advantage was, we could refresh single parts of the page instead of the entire page, and that led to faster response times. And the other thing is, before, on every interaction, we had to wait for the whole network request and the re-rendering of the page until we could do the next interaction. And with Ajax, all of a sudden, we could do things in parallel, right? We could make an asynchronous request to the server, and while this request was still in progress, we could keep interacting with the page and do other things that might trigger additional asynchronous requests. And yeah, that actually made it much more usable, and that just opened the possibility to build real front-end applications. But everything comes at a cost, and the cost in this case was complexity. So all of a sudden, we had more front-end code. As I mentioned, it was a lot of spaghetti code that was kind of hard to maintain. And it was the advent of asynchronous programming, something that still gives us headaches today. I mean, it's gotten better now that we've got async await and other mechanisms for dealing with asynchronity. But back then, it was just callback hell. So every request had a callback, and if subsequently, if you wanted to do another request based on the previous request, it had to be nested in a callback, and then you would end up with a lot of nested callback code, which nobody could understand anymore. And also debugging became more complicated because before you knew, okay, if there's an error in my application, I have to look into the backend logs, right? The application was the backend application. But all of a sudden it was like, okay, it could actually be in the front end or in the backend. I don't know, I have to investigate. And we didn't really have developer tools back then. So it was a lot of guessing and trying out, and yeah, console log. Was it even a thing back then? I think it was more like even logging in the DOM, seeing if things worked or not. And also part of the complexity was how UI got updated. Before it was kind of easy. Every time it was completely re-rendered. We knew, okay, the result of the previous action is this new page. Now it was like every action could update the DOM in 10 places or 15 places. And these updates could also easily get out of hand if you weren't really on top of your code. Also, more disadvantages, search engine optimization. Because not all of the content was rendered on the backend, these search engine crawlers couldn't parse the entire page if parts were loaded asynchronously, and therefore for application where this mattered, it was something that we really had to deal with. Also, Ajax wasn't available in all browsers from the beginning on, so you had to take care, okay, what do I do if a browser doesn't support it? We still have this going on today with Safari or other older browsers that are still around, but back then that was when this actually started. And asynchronous requests also opened new security problems. I mean, cross-site scripting and cross-site request forgery have been around before, but it was much harder to make an attack. With asynchronous requests, it was really easy. For example, I could, on my, if I had let's say a blog website which allowed users to post comments, they could just post a snippet of JavaScript that would, when another user displayed this comment, send their cookies, for example, to a malicious server. Yeah, that was quite easy to do, and nobody noticed it because it was asynchronous, right? It wasn't like, okay, you move to another site and would see, okay, something strange is happening, but it was done in the background. And also, using the back button got a bit troublesome, because before it was always clear when I clicked something, and afterwards I clicked the back button, then I would get back to the previous state. But with asynchronous DOM updates based on asynchronous requests, that wasn't the case anymore all the time. So what did we do to solve the problem? We came up with single-page applications, and that happened, yeah, around 2010, first with AngularJS, and then along came React, 2013, I think, and nowadays Vue.js, Svelte, and other frameworks which are still around today. So the philosophy behind single-page applications is you make one initial page load this first page, and then everything happens on this page. You never move to another page again. So the page is never reloaded. And from then on, you just fetch data from the server using an API. You use a REST API or GraphQL, and you update the DOM of this single page based on these state updates that you get from the server, or state updates that you do yourself in the browser based on the action that a user takes. So, and for that, we're using quite big JavaScript frameworks and libraries that we tend to identify with today. And yeah, it's working great, right? But also here, hold on. Let's look at the interaction first, how that changed. We've got this initial page request, that's still the same. And then we're moving away from updating HTML from the server. So we're not fetching these HTML snippets like before, but we make a request to perform an action. And this request usually returns as JSON data. And with that JSON data, we update the state. Like we've got a store where we manage all the state that our frontend application has. And based on that state, our DOM is re-rendered or updated, right? So actually there's not really HTML involved anymore. It's just DOM updates with JavaScript, and it's JavaScript everywhere for everything. So the advantage is, again, the user experience. We've got really fast navigation because we don't need requests between these single pages, because it's only one page, right? And all the navigations are just virtual. We can have really dynamic content. We're also not limited to having a backend server that provides us HTML that we can display, but we can connect to various APIs from our front end and fetch the data that we need. We could even fetch data from APIs that we don't own, collect this data in a store, render it, whatever. So a lot of possibilities. We can really manage a lot of state in the front end and just display small portions of it whenever we need it. And that's also great because this way we can have applications that work offline that store this data locally, and even when you're not connected to the internet or you have a flaky internet connection, they will still work because the state is local and not remote. And we have client-side routing, which means that we can also use the back button in the browser because, yeah, we've got this history API. Is it called history API? Not sure. Yeah. Yeah. Which allows us to have these URL changes without making requests to the server on every URL change. Cool, but also with single page applications, we've got several disadvantages. And again, the main disadvantage is complexity. We've got really big client-side applications that are hard to maintain. Developers need to learn a lot upfront. They need to learn about the framework itself. They need to learn about state management. They need to learn about all these third-party libraries that we use, these extensions that we use for our framework. Yeah, and also our framework has, or our application has a lot of dependencies which get bundled with our front-end application. So what that results in is that actually the first request when we load such an application, or the first rendering, it takes really long, right? We have to fetch this initial HTML, like we've seen before. It's always the same. We fetch an HTML page, but then we have to load this huge application, this huge JavaScript application, and parse the JavaScript and execute the whole JavaScript. So we've come up with a solution for that, and that's code splitting, right? But again, what does code splitting mean? More complexity, more things that can go wrong if we don't split the code correctly, if not all the dependencies that we have for a certain page are included within the part that we're actually loading. We have bundling, we've got tree shaking, which actually takes care of getting rid of all the codes that we have included in our applications, but we actually don't really need, because we've just included a library that has so much more functionality than we actually require. We've got state management, which can be a good thing, but it can also get a bit out of hand, and it's also something that you have to learn as a developer how to do properly. And we have sometimes quite some functionality or logic that's duplicated from the backend. For example, validation logic. When we have forms, then we might have front-end validations of these forms, front-end validation logic in our components. And of course, we have to do the same data validation in the backend as well. And unless you have a really good solution to that, things also tend to get inconsistent over time. That's all of a sudden in the backend, an attribute is required, where in the front end, we still don't expect it to be required. So then wrong data is sent to the backend, that rejects it. Then we have to handle that in the front end as well. All problems that we really didn't have before, and that exist nowadays because of our single application approach. So there are even more disadvantages. Big bundle to load, I've already covered that. SEO, of course, it's the same as before, but even more severe, because now even the first page that we present sometimes isn't rendered on the server. Of course, there's this server-side rendering, but then we still need this hydration logic and everything, and again, more complexity. We've got coarse issues because our application and where our front application lives and where the APIs live are sometimes different hosts, different places, and we have to take care that this is allowed in all the environments, that these are allowed to communicate with each other. And what I've seen a lot in single page applications are memory leaks and other cleanups that aren't performed, and that especially on applications that users use for a long time. For example, for our DevCraft Academy, I've used an e-learning system in the past, which had an admin area where you can feed in all the contents with a really beautiful interface. You could click together text paragraphs and headlines and images and, all these kinds of things. And when you feed in content into such a system, you sometimes spend hours, doing that job. And I realized, okay, after doing it half an hour, the interface suddenly got slower and slower. I wasn't really sure what the reason was. Maybe some event listeners that got attached to the document, for example, weren't cleaned up when doing this virtual page navigation, or some memory in the global store just grew without ever being cleaned up. So when you don't have a single page application, but you navigate from one page to the other, that's something that doesn't happen, because every time when you have this new HTML document, you also have a clear JavaScript runtime, right? You have a clear memory, you don't have any event listeners that are still lying around. So that's kind of an automatic cleanup mechanism that the original design of the web provides us with, that gets lost with single page applications as well. So is it really worth developing single page applications after learning about all of these disadvantages? And as always, the answer is it depends. I've got a little demo prepared for you where I want to show you a simple task application, like adding tasks, removing tasks, deleting. Yeah, just kind of the same, removing and deleting. So I'm just going to hit play here, or maybe make it full screen. So what are we looking at? There's this add link, right? I've also opened my DevTools, and you can see, okay, there's the first weird thing happening here. There are these turbo frame elements, which don't look like normal HTML elements, right? So when I click on them, we can see, okay, the link is in there. This also has a source attribute that I'll get to later on. And there's also another turbo frame with a different HTML ID called tasks, which is empty. So let's see what happens when we click this link. Okay, so the interface changed, and also the content of this turbo frame changed. But apparently we saw it here in the DevTools that this turbo frame was lighting up, but apparently it wasn't a full page reload, right? So it looks like this is a single page application of some sort. So when we keep going here, we can see, okay, the form inside. Yeah, so that's definitely this new task thing. And when I click cancel, then it's gone again, right? It's again this link with tasks new. So just to prove that this is not re-rendering the whole page, yeah, I make a selection up there, and therefore you can see, okay, if it was a full page reload, or even if the whole DOM content of the page was reloaded, then the selection would have been gone. Cool. So let's add some tasks here to see how this works. So I add buy milk, and we can see, okay, all of a sudden there's some content in here because there are these three dots, this ellipsis. And yeah, also when we keep this empty, then we have a validation going on here. So yeah, this whole thing appears to be really interactive, really dynamic. Also, when we edit it, it brings up a separate form in there. It's not like we jump to a separate page where this edit form is, like we would kind of have to do if it wasn't a single page application. And yeah, we can also delete things again. Cool. So far, so good. But now let's have a look what's really happening under the hood by, I think I have to make this small again if it works. Doesn't work.
Escape.
Yeah, I'm a little bit afraid of that. No, it works. No need to be afraid. Cool. So now let's have a look what's happening actually below the surface. So we start over again, and we have a look at the network tab. And immediately you can see when I click this add new, there's a request going on in the background, right? And when we have a look at the response of this request, we can see, okay, there's actually an H1 in the paragraph that don't show up in the result here. But there's also a turbo frame element, and it's got the same ID with the TurboFrame element that was already present in our DOM before. So it seems like the content of this TurboFrame element updates the existing TurboFrame element, which is in our DOM. Yeah, here you can see, okay, it's ID new task. And when we look down here, okay, there's this form, and also here there's the ID new task. So these match, right? Yeah, and the form is there now. So let's keep going. We enter buy milk into the field, click on create, and we can see, okay, it's actually two requests. Why is it two requests? So one doesn't have a response, or at least no body. It was a post request, and it redirected us. Cool. Because apparently it was successful, and we can see that we sent with this post request form data, so an authenticity token, which is for cross-site forgery protection, and this buy milk label. Okay, and then we were redirected to this /tasks URL, and there you can see again, okay, there's a TurboFrame inside, or actually there are several TurboFrames. There's this TurboFrame tasks, and then there's a TurboFrame nested within, which is called task 21. And that wraps this specific task, which gets displayed along with the edit link, with the delete button, which also looks like a link. Okay, so apparently what this does is it replaces this whole tasks TurboFrame container that we saw in our elements before. So now I've already gone further. I've hit the edit button, and again, this triggers a request to the server, and we get a TurboFrame back with this ID task 21. Now we remember before it was like the tasks TurboFrame that we received with the task 21 TurboFrame nested within, right? So this response only replaces the nested TurboFrame of this one task. And this is important because we want to be able, when we have several tasks, that only the one task is replaced with the edit form. So when I hit play again, okay, we can see that's the edit form. The edit form also shows up in here now in the task 21 in the DOM. And yeah, now let's update the task. So I've changed the text. I can see, okay, there was another request with a redirect. And yeah, I was redirected to the show page of this task, or the show action. And again, I received this task 21, which in this case is, again, the task's title. So the form is gone. And again, we have this edit link and the delete link. So you can already see a pattern, right? For every action that we take here, we send a request to the server. And the server replies with some HTML that needs to be inserted somewhere into our page. This sounds somehow familiar, right? Wasn't that like we did this whole Ajax thing like in the 2000 and somethings, like 15 years ago? Yeah, also deleting works, kind of the same. Deleting re-renders the whole tasks container because now, the list has changed, and therefore, this whole thing gets re-rendered. I think there's nothing more really interesting in this video, so I'll close it. So, yeah, again, the whole application works by sending requests to the server. Server sends us one or more UI or HTML snippets that should be replaced in the page. And yeah, but the whole thing seems quite interactive, right? And it appears to be similar to a single page application. So what do you guess? How many lines of JavaScript code does this app have, of custom JavaScript codes that I wrote?
None.
Yes. Yeah, 0 lines of Java. I mean, of course, there's JavaScript handling all this logic of making the requests to the server and then replacing the right turbo frame in the DOM with the right turbo frame from the response. But I mean, that's a library, right? It's this turbo frame library. You can use it for your own applications if you're using Ruby on Rails. That's really tightly integrated. That's how I stumbled upon it. But in the end, you can develop the whole application just by writing HTML, loading this one library, and then, yeah, having some server-side routes which return, again, turbo frames to the client. And the library takes care of updating the whole DOM and handling all the interactivity. So what's the advantage of this approach? Well, it loads significantly faster because all we need to load initially is the HTML page, some CSS maybe, and the TurboFrame library, but no custom JavaScript code, no bundle. We don't need to take care of code splitting. So yeah, it's a really lean and fast loading application. The UI is still snappy, although I have to say on a good network, because every time we interact with the page, we make a network request. So there we can already see where single page applications might have their advantage. The logic lives in one place, and that's on the server. So when we run into problems, we know where to look. It's definitely in our server-side application and not in our client-side JavaScript codes, unless we've come across a bug in TurboFrames itself. We have a consistent state with the server. That's also a problem we might encounter with single-page applications, that we might update the state on the client, but either we forget to update the state on the server, or there's a problem updating the state on the server, we forget to roll back the state on the client then, and all of a sudden things get inconsistent. And when users then visit our application again or reload the page, all of a sudden the state is totally different and they don't know why. Also not a great user experience. We've got less dependencies here. We don't need to load third-party libraries to the client other than the single TurboFrames library. And we've got less complexity because it's much more obvious where logic lives. There are also some additional features of TurboFrames. For example, I think you've seen at the very beginning, on a TurboFrame, we can also specify a source attribute. This is quite similar to how an iframe works, that we can provide a URL, and then we could actually leave the TurboFrame initially empty without nesting any HTML inside. And if that was the case, then it would immediately after the HTML was rendered and the TurboScript library has started up, it would fetch the additional content. So we could have a really, really fast first page load and load everything that's a little bit less important into a TurboFrame. This also works lazily. Similarly to how image lazy loading works, we can also provide this loading attribute to a TurboFrame. And what that does is, if this TurboFrame isn't in the viewport, either because we haven't scrolled so far yet, or because it was hidden with CSS and just became visible later on, then it would just load the content right when we needed it. For example, in our training platform at the DevCraft Academy that I've built, I've got some kind of an accordion for bringing up the list of lessons for a certain module. And I do it in a way that the accordion content is initially hidden, right? It's collapsed. And once I open it, I fetch the contents from the server, but I don't have to write any logic for that because that's just a TurboFrame and it has a URL. And as soon as this accordion opens, magically, automatically, the content of the accordion is populated from the provided URL. So, should we all use TurboFrames instead of single-page applications? And the answer is not, it depends. It is no, because it depends. It depends on the kind of application that you're developing. When should we use single-page applications? Well, if we really need rich interactivity. For example, Google Maps, yeah, should be a single page application. Also something like Airbnb or a social network where you have a lot of different kinds of data, a lot of options to interact with a page. That's better done in a single page application. If you need offline support, as mentioned before, in a single page application, you can fetch data up front, you can keep data in memory, so even when people are on a train or wherever where they don't have good internet connection, they can keep working with it. Google Docs is also a good example. Of course, Google Docs needs to be a single page application. If you have complex state management, and if search engine optimization is not a concern. So actually always when what you're developing is more of an application and less of a page, right? When should we use alternatives to single page applications? Well, if the applications are fairly simple, if we need to quickly develop something and we don't need the overhead of setting up front-end application, back-end application, setting up the whole build process and whatever, if we want to get started quickly, then this is a good option. If search engine optimization is important because we have all of the server rendering kind of built in intrinsically, and we don't need to add server-side rendering later on just to optimize for SEO. If the navigation is more page-based and less application-like, and if fast initial loading is important. I mean, when isn't fast initial loading important? But if you want to work with a fully fledged application, then usually you are okay with waiting like 2, 3, 4 seconds of the application loading initially, because you will then work with it for half an hour or an hour, and then it doesn't matter so much. On the other hand, if you have something that's more page-like, then you want to be able to access content quickly, right? You don't want for some information that you just searched for in Google, wait a few seconds until the whole single page application has loaded. And if you want to follow the path of progressive enhancement. Now, who of you is familiar with progressive enhancement? Okay, it hasn't been heard of since a long time, this concept, but initially, back in the days when we started using JavaScript for web development, our concept was that actually everything should work without JavaScript, and we use JavaScript to enhance the experience to just make the usability nicer. But even if for some reason, I don't know, JavaScript failed to load, there was an error in the JavaScript code, which also are cases that are still happening today, and therefore the JavaScript wasn't usable, the site would still work. And that, also isn't really doable with a single page application, but could be done with an alternative approach like turbo frames. So, one thing that I came up with were, I think single page applications are getting used more and more, but where I think it's really not a good use case are e-commerce sites. I don't understand why people develop e-commerce sites as single page applications, because they're page-based usually. So you navigate from page to page, and the pages are quite distinct. You don't have to interact with the pages usually a lot. Search engine optimization is critical. And what were the other reasons? I have to look it up again. And fast initial loading is also important. When you enter a product page, you also don't want to load this whole application just to view a product that you came upon on a search engine. So yeah, the conclusion is don't always go for a single page application just because they're the thing that we use today, right? Like before starting a product, consider your options. It's still okay, like we've heard before, to use just static HTML pages for some kinds of web project. It's still okay to use like old Ajax approaches with a new flavor, like we saw with turbo frames today. And it's also still okay to use a single page application when they make sense. Just use make your choices wisely, because these things always come at a cost, and that is usually mostly complexity. So newer approaches don't always mean that they're better, that from now on we should only use them anymore. Another example for me are microservices. Microservices are cool, but a few years ago everyone just started using microservices in the backend or as their architecture just because they were the new thing. And for many applications, they create more problems than they solve. And also there, one of the main problems is complexity. So yeah, consider always the trade-offs that a certain technology or architecture choice will present. Keep complexity low, and yeah, of course, use the right tool for the job. That's it. I'm sure you've got some questions for me, so shoot them at me.
Okay, good question is that we don't have any time for questions.
Really?
Yeah,
Well,
but I mean, if there are any question, quick, one or two we can bring in. Is there anything in the room? Because nobody sent anything in. Yeah, don't feel shy now because I said we don't have time for it. But okay. Anyways, we're going to make a 10-minute break, so we have some time to put the new computer up here. If you have any questions for him, then you can ask him outside, and nobody will witness it. So the next speaker can set up, meet you back in here, or if you stay here, meet you back concentrating to the front of the room. And there's free drinks in the fridge, there's nibbles there, there's goodie bags there, and there's rubber duckies everywhere. We'll see you back.
Cool.
You made it! Welcome to Vienna. We are so glad you're here. This event is part of Vienna Up, the Startup Festival. Have you got your Vienna Up wristband? Put it on and enjoy special offers and activities. Swing by the festival home base, say hi, hang out, and enjoy Viennese Hour to sample local food, wine, beer, and soft drinks for free. And have some fun while making new connections. Visit partnering traditional Viennese coffee houses to sip a free melange, meet new contacts, check your email, or just have ideas both crazy and grand. Enjoy Vienna. Go to viennaup.com, sign up for the newsletter for daily highlights, and we'll see you at the home base.
part of the talk. I thought there was something amazing coming up here, but it's just for its own health. So if you keep, when you want to talk to him later on, if you don't go too close, he puts his mask on again to make sure that you're actually not scaring him or like not appreciating that somebody is actually more safely, well, thinks about safety more than we do. Yeah. Okay, that was not good. Okay, Rainer Stropek is going to talk about server-side events, and when he turns off his mobile phone or tells his wife that he's busy right now. Who was it? So that's a 3-hour event in Vienna, isn't it? All right. Well, without further ado, so tell us all about server-side events and how they can actually help us with our performance bits.
Absolutely, I will. Thank you. Thank you very much for having me. I'm looking forward to spending an hour or so talking about server-side events. My name is Rainer Stropek. I am from Software Architects. We are a software as a service provider located in Leoningen-Linz. So I'm, let's say, a local here. If you want to keep in touch with me after this talk, feel free to use my digital business card. You can find it on the rainerstropek.me. And on the right lower side, you find all... Oh, my screen is not duplicated. Could you duplicate?
Okay, who's used server-side events before? Oh, that's one person. Okay, so if that doesn't work, you have to explain it to everybody else.
It now looks better. Let me turn off my audio.
Okay.
And here we are.
Are we back?
Not really. That's still not the correct screen, but I think I can fix that on my side.
Okay, so we are live again on StreamYard. Hello world.
So let's see. And last but not least, we have to change the screen resolution, and then we are up and running. So.
Yay.
Do we have StreamYard? Yes. Do you see my screen? Yes. We are up and running. Now we can start.
You're off to the races. Go for it.
Okay, very good. So, okay, now I can show you the website again. So if you want to keep in touch with me, I already said it. Visit my digital business card. It's available at rainerstropek.me. And on the right lower corner, you see a bunch of social media links. And if you want, you can find me on LinkedIn, for instance, and contact me there. That is fine. The whole sample that I'm going to show you today is available on GitHub. If you would like to take a look at the GitHub sample, feel free to do so. This is the QR code. If you want to take out your phones, take a quick picture. You have the entire source code that I'm going to show you in my talk today on this slide. It's available on GitHub for free. Of course, it's MIT licensed. Take it, use it, whatever you want. Just, I hope it's useful. I'm not having any slides, so we are just doing demos today. Okay, are we good? I think we are good. Okay, I recently heard that the time to first demo is a very important influencer when it comes to rating sessions. So I want to have my sessions high, so I'm going to keep the time to first demo very short, and we are going to jump right in with a small demo. This demo does not use server-sent event yet. It should demonstrate the core problem. What is the problem? When I take a look at a technology, I always ask myself, what problem does it solve? And that's the first thing that I would like to discover with you today here. So this is a small little Node.js application. It's using Express.js on the server side and Vanilla.js on the client side. So no fancy frameworks on the client side here. We are going to focus on fundamentals. So let's start by doing a post request, adding something to the router. I call it regular, something like this. And let's do an async call with a response here, something like this. And the ghosty little font, you probably already know that. This is from GitHub Copilot. I'm using GitHub Copilot here. So don't worry if you see this ghost font appearing here, that's just GitHub Copilot. That's just an AI helping me with doing some code. And as you can see, it already suggests a little bit of code, and I will simply accept it, but change this code a little bit, something like this. This is now a very trivial, let's say, HTTP handler. Essentially, it writes something to the log, but the important thing is this here. Imagine that you are building this great app, and doesn't matter if it's a server-side rendering application or an API, you do something which takes a while. You access the database, you access a web API, you access the GPT model from OpenAI, but it takes a while. It takes 5 seconds, 10 seconds, 20 seconds, whatever. It's not a good UI. It's not a good user experience if you simply display a waiting indicator to your end user. If the end user sits there and says, okay, I have no idea of this, if this thing died or if it's doing something. In this case, I'm just simulating a longer async operation. Could be a database call, could be a web API call, could be a call to an AI or something like this. And at the end, we send something back. Let's say we sent back done. That's a very simple API, and I'm going to start this guy up. Now we have our server running. It runs on port 3000. And last but not least, we are going to change our JavaScript a little bit, which runs on the client side. And in this case, I have implemented the necessary JavaScript code up front. So I copy it in, and I'll simply show you what I'm going to do here. I'm going to display a spinner here, something like this, a waiting indicator. I'm then calling this regular API using post and the fetch API on the client side. Okay, I'm measuring the performance, as you can see it here, and then I'm printing the result on the screen. Very, very simple. So let's call this thing localhost 3000. Executed. And now we have to wait. We have to wait. That is not very good user experience. Finally, after 5 seconds, we get something back. This is the first core problem that server-sent events want to solve. Imagine that you can break down this long waiting time, in this case just 5 seconds, but in your case it could be longer. If you can break it down into smaller pieces, maybe you can already send some of the bytes, some of the results to the end user, so the end user can start in his or her mind, process the response. This is what you typically know from ChatGPT, for instance. If you take a look at ChatGPT, you all know that ChatGPT is not very fast. If we take a look at ChatGPT, and I could, for instance, say, I am doing a talk at WeAreDevelopers here. Tell me something about their awesome conference. ChatGPT is slow, but what ChatGPT does, if I send this and if it works, I heard that they have some outages today, so it doesn't work. What you typically see is that you already get the first word. You get the first sentences. As a human, you can process the first sentences, and over time, ChatGPT has time to complete the answer. And that is exactly the problem that server-sent events wants to solve. You can process, you can do some processing in the backend, and you can send the user either a progress indicator, I'm 10% done, I'm 20% done, or a partly result. Typically, many people think that this is the perfect job for WebSockets. I assume that many of you have heard from WebSockets, right? WebSockets is an awesome technology that allows you to push data from the server to the client, but it also allows you to send data from the client to the server. WebSocket is a bidirectional protocol. Server-sent event is smaller. It's more lightweight. It can only send something from the server to the client. There is no back channel. If the client wants to send something to the server, it has to use something like a REST API. or GraphQL or whatever you want to use. So server-sent events is a lightweight option compared to WebSockets. So if your application has exactly the problem that I demonstrated here, you simply want to push out intermediate results to the client, then server-sent events might be a really good option. And I want to spend the rest of this session demonstrating to you what server-sent events is in very much details. And I want to demonstrate a sample where you see where server-sent events is used in practice, namely in ChatGPT. ChatGPT and the ChatGPT OpenAI API is using server-sent events heavily, and of course we are going to try that. So I hope I will be able to try it. Maybe you have read it in the news today. ChatGPT has a significant outage today. It's all over Twitter and whatever, but we'll see whether the API still works. So now we know what we can do. Let's do a more interesting example. And over the rest of the talk, I will not write so much code. I will copy code in, and I will walk you through the code that I copy in. So don't worry, you will understand every single line, but because of time limitations, I cannot write all the code. So take a look at this second API endpoint here. It's called streaming. Here, I would like to solve the problem without server-sent events. I would like to build, if you want, my own server-sent events. Is it possible using regular HTTP to send chunks of results from the server to the client? Obviously, it is. And by building it on our own, it helps us to understand what server-sent events really is. So let's take a look how this method really works. The important part here is this one. The first thing that we always have to send back first is the HTTP header. We have to write the header. We have to tell the browser, okay, we are good, HTTP status code 200, and I'm going to send you some content. In my case, just text plain content, but of course you can also JSON or whatever you want. Then I am splitting up the long-running operation into parts, as you can see it here. And the important part here in this Node.js application is this line here, response.write. This takes a bunch of bytes and sends them immediately from the Node.js application to the browser client. So the browser client will receive only a fraction, only a part, only a chunk of the HTTP response. The connection will be kept open. So in the next iteration, I can again wait for another second and send the second chunk. And then I wait again for another second and send the next chunk. This is exactly what you often have in your application. You are doing some calculations and you have some intermediate results. Why not sending them already to the client? Why waiting until you have everything ready on the server side? Okay, this is regular HTTP, no framework, no SSE, no WebSocket. It really works like a charm. At the end, we simply say response.end, and that's it. So the server part is really not difficult. The only thing that I changed here in Node.js is this response.write as compared to a response.send that I had before. Now let's open the client-side JavaScript and copy the next part in it, and I will show you what I changed here. Now, this is the second client-side application. Until, where is it? That's the long-running streaming. Until here, everything is identical. So this is just displaying the spinner. This is just doing the regular fetch operation. But now, as compared to before, I'm not accessing the text here. Text is the entire content of the HTTP response. I'm using something which is called a get reader. I'm getting something back which is called a readable stream default reader. That's a built-in concept in every browser. Your JavaScript in the browser has this stuff built in. Then I can read a chunk of what the server already sent me. And then I can use a so-called text decoder to decode the value, which is just a byte array. The text decoder is required to turn the byte array into UTF-8, into characters. So I'm receiving a chunk in form of bytes, turning it into a string, and in this case, I'm just concatenating it onto a a pre-tag, so nothing special. And let's see how this changes the whole application. Let me start my app. Let me restart my app. Let me go back to this demo and then do the streaming request. I will open up the networking tab here so we can inspect what's going on. And we see that here we have one HTTP request. It's still in flight. As you can see, we get our data. That's a loop over 10 iterations, so from 0 to 9. And if we take a look, the entire response was the whole data. But we didn't get the data entirely in one go. We didn't wait 10 seconds and then send everything, but we used response.write to send a little bit, an intermediate result to the client. Not very fancy, right? Not very difficult, but the user experience is drastically different. If we wouldn't have done that, the user would have to wait for 10 seconds until she sees anything. Now we have to wait 1 second until we see a little bit, and that might already be useful. Good? All good so far? Nice. So this was something like server-sent event manually built. Now, many years ago, somebody has had the smart idea that this pattern is something that people use pretty frequently. So it would be a good idea to take this pattern and embed it deeper into the browser's API. Why not support this pattern natively? And that's exactly what server-sent events is all about. Sending data from the server looks nearly identical to what you saw just now. But receiving the data on the client side is much simpler because we have dedicated support from various JavaScript classes, which I will present to you in a second. Okay, so let's take the next example. Here it is. Go into the server-sent events here and put the next piece of code that I've prepared for you here. So let's take a look. As you can see, we start by sending the HTTP header just as before. Nothing special. You see, we are sleeping a little bit, we have our for loop, and we send the data just as before with response.write, exactly as we did before. But the huge difference is this part here. Do you see this data colon blank, and then we have data something? This format with the key at the beginning, then the colon, and the double backslash ends here at the end, believe it or not, that's the SSE protocol. It's as trivial as that. You simply use key value pairs. The key is in front of the colon, the data is after the colon, and every message must be separated from the next message with 2 backslash ends. That's it. You've just learned SSE. In my experience, simple protocols are the most important and most successful protocols, and SSE is exactly that. It's simple, but it's very easy to work with. Okay, the rest is exactly as we did before. The only special thing that you see here is at the end, I'm just sending data without payload and double backslash n at the end to the client. Keep that in mind. This will be important. Good. So let's go back to the client side and add a little bit of code to our client side. Where is it? Yeah, this is the right one. To our client side application. And let's take a look at this code. Now here, again, the spinner and things like that. But here, you see that one? No longer fetch. I'm using a class here which is called event source. And event source is the client for the SSE protocol. Event source is built in all major browsers for a long time. Event source is simply saying, hey, browser, don't wait for an entire HTTP response. Just interpret the chunks that you get from the server according to the SSE protocol. So there will be a key, then there will be a colon, then there will be double backslash n at the end. That's exactly what event source does. And on this event source object, you can then register event handlers, in this case on message. And this on message is simply there to process the data that you just got. And the data here, this stuff here, that is just the right part, just the right side of this key value pair. So the parsing of the message is done automatically by this event source guy here. But this event source guy has a lot of tricks. And one of the most important tricks is retry. If the event source recognizes that the server terminates the HTTP request, but the client would still be ready to receive something, then the client event source assumes that the server died. Maybe the internet connection was broken, maybe the server was poorly programmed, it simply died. And what it will do, it will try to automatically reconnect. It will call the server again without you having to do anything and say, hey server, I'm ready to receive something, send me additional data. That is what event source does. So auto retry. Therefore, it is important that the client terminates the SSE connection. That's an important one. And this is exactly why I told you should remember this one. Here, the server sends to the client a notification message, in this case, empty payload. Hey, I am done. Don't expect anything else from my side. And what does the client do? The client checks whether the payload is empty. And if it is empty, it closes the event source on the client side. And by closing the event source on the client side, no retry is done anymore. Got it? You will see a retry in a second, okay? Well, that isn't very complicated. However, event source has a bunch of drawbacks. Event source can only send HTTP GET. It's only HTTP GET. You cannot tell event source, hey, I want to have server sent events, but I want to have it using a post request. Sorry, doesn't work. Therefore, if you want to send parameters through event source, you have to do it through the URL. You cannot send a JSON payload, for instance. Doesn't work. You cannot influence the HTTP request headers. Event source doesn't support setting event headers. So unfortunately, if you, for instance, want to send a bearer token or something like this, I'm super sorry, doesn't work. You have to find a different way here. Maybe cookie, something like this. Could be a possible option, but no custom HTTP headers. Okay, so event source is somewhat limited. However, it's useful, and of course, we are curious and we want to see whether our application works. So let's reload that one and try to use this first thing. I will again get up my networking tabs here, click on this one, and oh, sorry, this one. And here we see it. And please note that one. Do you see that? That is new. That is a new part here in the Chrome developer tab. It automatically recognizes that this is using server-sent events and an event stream, and therefore very similar to sockets. You can see the messages that go over the wire. And here you see exactly this was the payload, and this is the final message with the empty payload that triggers ending of the SSE communication by the client. See? Works nice, right? So we have dedicated support on the client using event source. On the server side, it's really trivial. Just a little bit of string manipulation and you're good. Are we good? Fine? Good. Next step. Let's stay here in this example and let's copy in the next step. This one. Yep. No, that's the wrong thing that I just copied. I'm super sorry. This is what I want to copy. Now it's good. I didn't tell you the entire truth. I'm sorry. I simplified the SSE protocol a little bit because in real world, the SSE protocol is more powerful. And here you see nearly the entire beauty of SSE. Nearly. There is one additional thing coming up, and I will show you that. In real life, in reality, you cannot just send data, but you can also send named event types. So the SSE protocol supports to send first a key value pair where the key is the keyword event : Then you can specify any event type. That's just a string. You can name your event. And in my case, I wanted to keep things very, very simple by saying if I is a even value, I send the event type even. And if I is an odd value, I send the event odd. Please use your imagination. You can use that for whatever message types that you want to send. Just use any kind of name spacing, for instance. Then please note that we only have a single \n here. Then we send data and any value. And in this case, I just wanted to use a JSON payload here because I thought it would be nice to demonstrate that this can, of course, be JSON, obviously. And then note \n. These \n separate two messages further. Got it? So we can have named messages. A little bit similar to SignalR. Anybody familiar with SignalR? Ever heard? SignalR has a similar concept, and this is very similar to SignalR, but it is built into the protocol. WebSocket doesn't have message types, but SSE does. And at the end, I am sending an event which is called EOM, which stands for end of message with an empty data payload to again signal to the client, hey, terminate the connection, I am done. Good. Let's add the client-side part. The client-side part looks very similar to what we had before. Before, we had this on-message event handler. See it here? But if we use custom events, we don't use on message anymore, but we simply add event listeners, as you can see here, to our event source. We say, if you get an even message, then do something. If you get an odd message, then do something. If you get an EOM message, then do something. So it's really, really simple on the event source to say, hey, handle this type of message or handle this type of message. Very, very simple. The rest is exactly as we had it before. So let's run this guy here, reload it, and try the custom events. Here we are. This is it. And if we take a look at the response part, do you see the messages coming in? You see the event types? And this is exactly what you see here. On the client side, we simply say even, odd, even, odd, even. When we receive the end of message, we terminate the event source. We are good. SSE has come to an end. Yeah, fair? Good. Are you ready for the third level of our SSE? The third level is message IDs. Let me show you what you can do with message IDs. Here we are. And I promise this is now really SSE in its full beauty. Nothing more. That's it. We already know about events. Fine. We already know about data. Fine. But now I add a third thing here, which is called ID. What is this ID? ID is a number. It's just a number. It can also be a string. You can send whatever you want. You know what this ID is for? For retry. Imagine that the client recognizes that the server just disappeared. Maybe an internet glitch, maybe a bug in the server implementation, whatever, the server doesn't send anything anymore. And the client reconnects. But what should the server now do? Should it send everything from the first message again? If the server sent an ID to the client, then on reconnect, the client will automatically take the last ID that it successfully received and send it back to the server when it retries the connection. So the server can take a look at the message and say, oh, the client received ID, I don't know, 4711, something like this. And then the server can come up with a strategy to continue with the next message. Understood? So this is another level of optimization of the client so that we do not send everything from the very beginning again. So let me demonstrate how this is done. And for that, I inserted here, I inserted a mistake. This mistake says, hey, if I reached message 5 as a server, I suddenly break. I suddenly return. I stop sending anything to the client. And if we are right, the clients should recognize that the server just went away, and it should reconnect and send the last event ID, which you see here, through an HTTP request header. So the client sends the last successfully received ID through a custom HTTP request header to the server. The server gets this custom request header and can process it accordingly. In my case, I'm just picking up the ID, adding 1, as you can see here, and I'm sending the next request. So when this message terminates with 5, it should continue with 6 after a reconnect. Got it? Let's try it. Let's put the client code, very simple vanilla JS code, here, reload this thing, go here, ID. And as you can see, we are receiving things 0, 1, 2, 3, 4, 5, and something bad happened now. Something bad happened, and do you see it here? See this one? This is the retry. SSE automatically retried, and if we take a closer look at this request, you will see that in the request headers, somewhere here, the client sends to the server, I successfully received message with ID 5. Please continue with the next one. So the server can recognize that and start with value 6. And this is exactly what this whole SSE protocol with the ID is all about. It enables you to continue after the last received message. You good? Good. Now, this SSE stuff is really pretty old. It's not a new thing. It's not a flashy new thing that people were talking at conferences anymore. If you take a look at conference programs in the last few years, I guess that you will not find any talk about SSE because it's very simple and it's pretty old, and most people nowadays use WebSockets because it offers a duplex communication, and with a library like SignR, it offers a lot of power, even more power than SSE. No questions about that. So why am I standing here talking about SSE? Why do I think that SSE suddenly has a kind of renaissance? I can tell you why. Because of this small little company here. Has anybody ever heard about OpenAI before? Let's do the show of hands. Has anyone used products from OpenAI before? Yeah, you did? Well, me too. So I hope that their website is still here. Yes, it is here. Let me quickly sign in. I thought I signed in before on this laptop, but maybe it's because of their downtime that I've been thrown out again. So let me zoom in a little bit. Let's go to the API reference. And if we go to the streaming part, do you see this one? Server-sent events are all around. It's all over OpenAI. If you use OpenAI and if you use the streaming technology from OpenAI, you must use server-sent events because this tiny, teeny little company, which has a small amount of users out there, they decided to use server-sent events. And suddenly this protocol is interesting again. Suddenly we have to remind ourselves what SSE is all about because many of you are going to write client applications using the services from OpenAI. And this is the reason why I'm standing here. I want you to be equipped to use the OpenAI API. If you want to use the OpenAI API, you need to be familiar with WebSocket, with server-sent events, because this is what they use. So let's see whether they are available again. Let's try it again so that you know what I mean. Hi, let's see. Nope, still down. Let's see if the dashboard works. Let's go to the chat here and say hi. This is not ChatGPT. This is, oh yeah, very good. I have to ask it a more complicated questions. What do you know about WeAreDevelopers? Let's try it, okay? Let's try it. And do you see what's happening? This is server-sent events. You see how the text is flowing in? This is streaming. This is exactly what I showed you before. And this is the reason why we talk about it. So let's take a look at the docs. I'm glad that the API still works. Let's take a look at the docs and take a look at their new assistant API. Here we have the runs. Here we have the create run. For those of you who are not that familiar with create run is a REST API call with which you can ask OpenAI to process a conversation, a so-called thread. So you add messages to a thread, and if you want the AI to generate some text, you say, take a look at this thread and generate the response. This is what we are talking about here. I'm talking about the new preview API. I'm not talking about the old, boring production stuff. Strange times, right? The production stuff is old and boring, but this is the hot new stuff, and they are making it available here on this API here. And if I scroll down a little bit, you will see that they have a stream flag here, which is Boolean, where you can say, yes, please stream. If you do that, if you say stream, then you are not getting the entire HTTP response that you see here, which is a pretty complicated thingy here. But if you say stream the result, you suddenly get something which you are now familiar with. Do you recognize the SSE part that we just worked on? You see that they have defined a number of event types. Run created, run queued, run in progress, run step created, and somewhere down here we see thread message delta, delta, delta. This is exactly where ChatGPT sends you token after token after token. And as a good citizen, you take these tokens and you immediately display them to the end user. You do not wait until ChatGPT is done. You write every single word immediately on the screen. And they use SSE for exactly that. But wait a minute. We have a problem. Houston, we have a problem. Can you remember what I told you? Exactly, it's get only, but they use post. What the heck is going on here? Well, the reason is simple. Their API was never intended to be used by the browser client. Please, please do never call the OpenAI API directly from the client. You will need to send through a super secret high security token. You should never do that from the client. So what you typically do is you consume this API on the server side. And you do not consume this stuff manually. You use their APIs. They have an NPM package that you can use. They have a pip package if you use Python. Microsoft provides you with a NuGet package if you want to use .NET. So behind the scenes, they are using SSE, but you, as a developer, will not see that. You simply use their API, and it will show you how this looks like. But at the end of the day, it's not enough if you just say, okay, I'm using their APIs, because at the end of the day, you will have something like this. You have the client here, you have your app, your server here, and you have OpenAI here. So the client sends his question, your app sends the question to OpenAI, and now in green we use SSE, sends a token, sends another token, sends another token. So this part here is covered by the OpenAI SDK, JavaScript, C#, Python, whatever you use. But somehow you have to take these tokens and bring them to your client. And this is exactly where you, on your side, can use not SEE, but SSE, server sent events. And there you can switch from post to get, and you can use event source again. Got it? Fine? So SSE, behind the scenes, not your job. Done by the SDK. To the client, very cool protocol. No question about that. Now let's take a look at the code. I told you that you can take your time to take a look at the code. And now, oops, sorry. I copied something wrong. So, yep. This is what I wanted to copy. I make so many copy mistakes. Imagine how many mistakes I would do if I write this code by hand. I thought about what I should do, and I'm now taking a look at my friends from WeAreDevelopers, and I thought I'm going to create a bot which is, I'm sure, very near to their heart. Because, you see, I say, hey, let's build a WeAreDeveloper bot. The bot helps developers to argue why they must visit the WeAreDevelopers conference. The bot must be able to provide you with arguments to convince your manager that you are allowed to attend this awesome conference. And to have a little bit of fun, I say your suggestions should not be too serious. They should be fun and engaging. Feel free to throw in some emojis, just so that we have a little bit of fun, okay? Let's see what ChatGPT thinks about the WeAreDevelopers conference. We are here at WeAreDevelopers, so I thought this might be funny. So let's take a look at the implementation. As you can see here, I'm using the JavaScript SDK of OpenAI. I'm creating a thread here where I say, give me 5 reasons that I can present to my manager why I have to go to the WeAreDevelopers conference. Okay, awesome. And then I create the run. See it here? And ladies and gentlemen, this is the magic of SSE. Behind this for await loop in JavaScript hides the whole SSE magic. The SDK of OpenAI takes the chunks which come in through SSE and provide them asynchronously to a for loop so that you, as a developer, can simply process the chunks that come back from OpenAI in a very, very simple way. Okay? And how do I send it to my client? I'm using the SSE protocol in exactly the way that I showed you before. Are we good? Good. So let's copy in the client-side code. And I think my friends from WeAreDevelopers are now getting more and more nervous because they have no idea what ChatGPT thinks why you should go to their conference. No, I'm just kidding. I think if it doesn't work, don't be angry with me. We'll see. I mean, it's AI. So you see, on the client side, it's exactly the same code as before. I have my event source. I'm calling this backend message. I'm terminating the SSE transaction using event source close if I get the last message, and so on and so on. Really, really simple. So let's see. Let's remove that one. Give me 5 reasons that I can present to my manager why I have to go to the WeAreDevelopers conference. Execute. Let's see. Of course, happy to help. Light up our project pipeline. Networking ninja. Idea extravaganza. Brand ambassador potential. Motivating magic. And yes, I can send you this text for your next press announcement. I'm super happy to do that. No, I'm just kidding. You see, did you recognize, and that's the serious technical part, do you see the streaming? We used SSE from OpenAI to our Node.js server, but we didn't see the SSE. It was hidden behind a beautiful for await loop implemented by the OpenAI SDK. And then we used the SSE protocol to stream the result, maybe pre-processed. In my case, I'm pre-processing it by turning Markdown into HTML, pre-processed to the client, and the client does really the step-by-step visualization and has a good user experience because the user does not need to wait until the entire generation process was done. The user saw intermediate results before. Absolutely, I can go to the DevTools. No question about it. I will run it again, so we will get even. You just want to have 5 additional reasons. Why? I'm pretty sure about that. So let's call it again. And here you see it, and here you see the event stream. See? Is this what you wanted to see? Yeah. It's a mini vacation. Oh, I like that one. Swag and cool gadget galore. I also like that one. So ChatGPT is kind of funny if you ask it to be funny. Yeah. Okay, let me quickly close before. So that is what I wanted to show you. So now we can go into a Q&A. I hope the demos were clear. I had 2 goals in this session. First, I wanted to show you why SSE is a useful protocol and how it works. And then I wanted to show you how OpenAI uses the SSE protocol for streaming and how you can use the SSE protocol to get the streamed results from OpenAI to the client. Thank you for listening. Thank you for attending. Let's now open it up for Q&A.
Excellent. Thank you so much. This was amazing. Two things that I found when I give a lot of talks about UI and UX and AI, basically how to display AI without being annoying to the end user. And one of the things was that typing, the answering coming back is an accessibility issue for somebody who's neurodiverse or somebody who actually has turned off animation in the operating system. I always thought this was a CSS animation, but now I know it's just the data coming in.
Yeah,
it's
how
still an
the
issue,
LLM
though.
works. It's really how the LLM works. The LLM in the background generates token by token by token. So you see the first results while the LLM in the background, somewhere in the Azure cloud, is still thinking.
Okay.
Yep.
But it's an interesting one. It's a UX problem now that we have to solve. But
yep.
I love that it's a very old technology that actually is being used again right now, and the lightweightness compared to sockets is quite incredible.
Yep.
So one question we had from the online audience was to how long does the event source live until when there's no data being sent? Is there a timeout?
You mean this? There is a timeout, but not from the event source, but typically from the underlying network connection. So if you have a browser client that connects to a server and the server does not send back any responses, you typically over the internet have some network devices in the middle terminating the network connection after a certain time of idleness. What I didn't show, and thank you for reminding me, is that there is in fact one additional thing to mention. We have, let me see if I can find it here. No, that's the client side. No, it's not the client side. Here. What you can do is you can send comments over SSE. It doesn't make a lot of sense to make a comment, but the comment is sending at least some bytes to the client. The client will ignore this comment. But this is a kind of keep alive message, so you can make sure that the connection isn't terminated over the internet somewhere. The server can send, let's say, every 20 seconds or something, a few bytes to the client, so nobody will cut the connection because of idleness.
And the comment starts with a semicolon.
Yes, it starts with the starts with the semicolon. Yeah.
Okay. Any question from the audience? Now
I think we had one
come with the microphone so people online can hear you as well.
Thanks for the talk. It was really interesting. I've just got a question regarding the last example where you are receiving data from OpenAI on the Node.js server and then passing the data or more or less the same events to the client. You pre-process them a little bit. But in case you didn't pre-process them, would you also be able to use Node.js streams to just pipe the stream you receive from OpenAI directly to the client without having any code to write other than this connection, this piping?
Probably it's just HTTP. I have never tried it because in real life, I never had a situation where I could, without any changes, send the results from OpenAI directly to the client. Typically, I always have to pre-process them, but it's a good question. I guess you could, but I've never tried it.
Any other question?
Yeah.
You were talking about the IDs and the retrying.
Yes.
And is there some way how to limit the number of events stored on the server? Because if the client would disconnect and then it would take week or month, the server would run out of memory, right? So because it would have to store all the events somewhere, which should have been posted to the client. So what's the best approach to limit the number of the events which are stored on the memory on the server, or what's the approach how to handle this?
It heavily depends on the application. In some cases, you do not need to store anything. For instance, if you take a look at my OpenAI sample, I'm not storing anything on the server. If the message terminates, I can simply go on and forward the next words, and maybe the client will miss some tokens, but I simply don't care because it's not critical. And on the other hand side, I could imagine some business applications where you really need to buffer data on the server side and resend, so catch up when the client reconnects. It heavily depends on the project that you are building. But then for my talk today, it's important to note that the server-sent events protocol is completely agnostic about that. It's essentially your problem. If you don't have to store anything, don't store anything. If you are afraid of a memory overflow, store your data in something like Redis or a database or whatever. It really depends on what you want to achieve, but SSE does not help you, but also does not stand in your way.
Any other question? No. This doesn't work that way, so people understand will not hear you. You have to wait for the magic microphone.
Hello. Is it possible for AI-generated pictures to make an SSE or not?
First, the OpenAI API has very limited support for generated images, but I can imagine that you maybe ask not just for OpenAI, but for other APIs. As long as you can put the result into some chunks that you can send to the client, you are fine. I guess that you would do it probably differently for pictures, because pictures are not sent line by line, but pictures are typically sent in a smaller resolution, and then the resolution gets better and better and better and better, so you are sending more and more and more bytes for the same image. So I guess you would maybe use a different approach. Could you use server-sent events for that? Of course you could. You could base64 encode the data of your image and send it back, but I could think of other approaches too, where you simply generate an image with a very low resolution, then send the URL using SSE and say, hey, this is the current version of the image. And then you generate a new image which has a better resolution, and you send only the URL of the better image now using SSE. So probably you would combine SSE with other technologies. Like, for instance, if I could think of my home cloud, Azure, I could think of Blob Store, something like this in combination.
Blob
something like this. Yep.
It reminds me of one of the weirdest things I've ever seen. One of the earliest bits of before Ajax, there was an online chat where somebody used image magic in Perl on the server to generate an animated GIF and never sent the final sequence. So every time you typed something in, it put another frame inside the GIF, and the browser kept loading it, and it crashed after 3 minutes because it was Netscape. But basically, this was the first idea trying to do that.
Really nice demo.
The traffic would be horrendous, though. That's the issue with that, I guess. But yeah, it's an interesting approach, and it was also interesting to see that ChatGPT is down, and at the same time, GitHub Copilot keeps telling you that how to fix your code. So it's like two AI companies battling it out. It seems.
I think that only ChatGPT is down. It's not that GPT and OpenAI is down. So I'm using the API here, and GitHub Copilot is also using the API in the background. So I think only the UI, the ChatGPT UI, is down today.
And it's got a Microsoft internal one, I guess, not the public one.
The GitHub Copilot, yes, but in my demo, I used the OpenAI one.
Cool. Yep. Any other question?
Yep.
I have one more. Is there any limit to the simultaneous connections being handled or being waiting for the response on the server? For example, if I implemented a chat app for some reason, and the chat app have millions of users, what should I do to mitigate this this limitation?
Yeah, very good question. Very good question. First, for a chat app, I would personally prefer WebSockets over SSE, but the problem is exactly the same. In the demo that I showed here, and in the way that OpenAI uses SSE, is they use SSE for short-term streaming. So what they do is when they start generating an answer, until when they are done generating the answer, the SSE connection only lives for these few seconds. You could imagine a different application where when you first load the application, maybe a single page application. You open an SSE connection to the server and you keep it open for the entire time that the user keeps his browser tab open, for instance. So it might be open for minutes, hours, days, if you want. If you build an application like that, you will end up with the server having to deal with lots and lots and lots of HTTP connection. Now, how can you deal with that? On the one hand side, you can use a web farm which is sufficiently large. So your SSE connections will terminate on some farm clusters, but what you will have to do is you will have to implement some backchannel communication between the different web farm nodes, so that all the web farm nodes can offer a common, let's say, memory or database for the chat application. So user 1 terminates on server A, user B terminates on server 2, and they have to know each other in order to do the chatting. Using a protocol like WebSockets, you can buy cloud-based cluster systems. In Azure, for instance, there is a service which is called Azure Signal R, which takes away the entire load balancing of permanent WebSocket connections to your application from your application. So you pay Microsoft a few bucks per month, and they are capable of terminating tens of thousands of simultaneous connections, and your application don't even see these connections. There is, to my knowledge, no cloud service for server-sent events, because as I told you, in this application, you don't have this problem, because the connection is only open for a few seconds and is then terminated. Does this answer your question? Okay, thank you.
Another option would be to use a peer-to-peer web torrent or something like that for a chat, so it scales with your users rather than, or the users' machines rather than a cloud server in the middle. There's a great company called Socket Supply that does a lot of like app distribution with peer-to-peer, and that's a very interesting approach as well, because I knew Spotify was a BitTorrent client under the hood when they started. So every user playing an MP3 would also distribute it to the other listeners. It was a very clever way to scale very quickly, and then the music industry didn't like it. So I guess we could ask for hours, but we also want to go further on with the event, and we also want to go to the outside drinking, smoking, whatever we're going to do on the balcony. So thank you very much.
Thank you.
Rainer. Thank you very much, Clemens. A big applause for both of them. That was a really good session. And now we're going to go and do a quiz round, which you can take part as well if you want to, where you can actually join us on Slido to win tickets for the event. And to the people who are going to be here get a goodie bag and the tickets. The people who win online will have to contact us at help@wearedevelopers.com or chris@wearedevelopers.com and then get the information that way. So these are all going to be questions about web performance. I didn't write them, but I probably know the answers, so we're going to see. So maybe I find a ticket to get there, so that'd be fun. So let's see how many people are joining, and then we see how many we have to deal with. Okay. And nobody used a funny name yet, so I'm happy about that. We don't have to blur anything out of the screen so far. I like how somebody says, like, I'm going to be the fastest and only type like 3 letters, and the others type their whole names and like family name and like. Shall we? Guess we start if we get 40. Yeah, okay, it's stalling. 24 is a good number, isn't it? It's almost 42, so all good. Okay, then let's get started. What is the primary goal of reducing layout shifts in web performance optimization? Remember, speed of answering is as important as the right answer. $18 people, 19 people. 10 to go, or to despair because they don't know the answer. 31 people, so the end post has been shifted. Will everybody be ready? Almost there. Okay. So let's take a look. Most people said the primary goal of reducing layout shifts in web performance is ensure visual stability for a better user experience. And of course, that is the correct answer. Cool. Second question of 5. Which of the following features of HTTP2 significantly contribute to improved front-end performance? File compression, server push, caching, or increased security? 33 people in the running now. And 2, 1, dun, dun, dun. Okay. Oh, quite a split. We got file compression, 36%, server push, 21%, caching, 39%, and increased security, 3%. I guess it did a lot of those, but the right answer was server push, 21%. So not as many. Most people thought caching was the thing. It wasn't. It doesn't do it for you in HTTP2. So, third question of 5. Which technique is most effective in optimizing the critical rendering path? Using a service worker for caching, minifying CSS and JavaScript files, increasing server response times, and adding more third-party JavaScripts. Dear Lord. 28 seconds to go. 2 of 33 people already chose to say what they thought was right. Six, 5, 4, 3, 2, 1. And let's see what people thought the answer was. Minifying CSS and JavaScript files is a clear winner, followed by service workers for caching and increasing server response time. Nobody has any love for adding more third-party scripts, and I'm very happy about that. So let's see what the right answer is. It's minifying CSS and JavaScript files. Excellent. So we don't have to do that by hand any longer. And that most of the systems allow us to do this now. So 4 or 5, what's the next one? How can you reduce time to interactive TTI on a web page? Lazy loading images and videos, using a CDN, preloading key resources, and reducing JavaScript execution time. 29 seconds to go. 7 of 34 people already answered. Ten, 9, 8, 7, 6, 5, 4. I'm not stressing you, am I? 3, 2, 1. And what did people say? Lazy loading images and videos, clear winner. Then preloading key resources, reducing JavaScript execution time, and utilizing a CDN. You should be punished for using a word like utilizing. That's just not English. That's a very, very marketing word. So what was the right answer? It was reducing JavaScript execution time. So most people got it wrong. That makes it interesting. 5 of 5. What's the last one? What impact does first contentful paint have on user experience, and how can it be improved? Faster FCP improves perceived loading speed. Slow FCP increases bounce rates. Using server-side rendering can improve FCP. Increasing server response times can improve FCP. 4 people already know it. Others have 20 seconds to go. Bounce rates always sounds like something fun, but isn't. It's kind of a shame. All right, and all are in. Most people thought it was improving perceived load speed. Then we said like using server-side rendering can improve it. Slow FCP increases bounce rates, and increasing server response times can help was the last. So what was the right answer? Faster FCP improves the perceived loading speed, the first one. 45% got it right. Which brings us to the final score and actually to see who has won. And Clemens is the first one to win. To get interesting to see because you're already coming to the event, right? But okay, followed by Victor. Who's Victor? Is there here in the room? Excellent. And Jack. Jack's online. So Jack would get has to send us an email to help@wearedevelopers.com or gmail@christianheilmann.com, which is also something I set up. And then, come again? Oh, he also has to give a screenshot of the winning thing. So anybody now taking a screenshot of that and faking it can send us something in and pretend to be Jack. We'll find a solution for that. Not an issue at all. So if the winners want to come, up here, then we got a goodie bag for you and we got your tickets for you. And that means that's the end of the stream and it's the end of the event. Thank you again for joining us online for a live thing. And now we're going to do more party here in person and unspeakable things that we can't show on the internet. So thanks for joining and thanks for being here. And we're going to hand over the prizes now. Thank you.
You made it. Welcome to Vienna. We are so glad you're here. This event is part of Vienna Up, the Startup Festival. Have you got your Vienna Up wristband? Put it on and enjoy special offers and activities. Swing by the festival home base, say hi, hang out, and enjoy Viennese Hour to sample local food, wine, beer, and soft drinks for free. And have some fun while making new connections. Visit partnering traditional Viennese coffee houses to sip a free melange, meet new contacts, check your email, or just have ideas both crazy and grand. Enjoy Vienna. Go to viennaup.com, sign up for the newsletter for daily highlights, and we'll see you at the home base. You made it. Welcome to Vienna. We are so glad you're here. This event is part of Vienna Up, the Startup Festival. Have you got your Vienna Up wristband? Put it on and enjoy special offers and activities. Swing by the festival home base, say hi, hang out, and enjoy Viennese Hour to sample local food, wine, beer, and soft drinks for free. And have some fun while making new connections. Visit partnering traditional Viennese coffee houses to sip a free melange,